Alright, so in this lesson we are going to talk about MBPO, I mean model-based policy optimization. The main idea behind MBPO is to get the best of both worlds: model-free reinforcement learning, which is usually reliable but slow, and model-based learning, which is fast but can be inaccurate. MBPO mixes the two in a way that improves sample efficiency. Let's break that down a bit. Normally, if you want your agent to learn something, you would have to interact with the real environment again and again. That takes time and sometimes it is expensive. What MBPO does instead is it learns a model of the environment. So now the agent can simulate things internally, sort of like imagining how the environment would respond without having to always ask the real one. That being said, it doesn't just rely on the model all the time. It still checks back in with the real environment regularly to make sure it is staying on track, because the model can make mistakes, especially as it looks further into the future, and that's something we will come back to. Okay, now let's look at how this works in practice. Here at the top we have got the dynamics model ensemble. What this does is try to learn the probability of what happens next given the current state and action, and you will see the formula here. So that's the probability of the next state S prime, and rewards are given the current state S and the action A. We don't just use one model through, we use an ensemble, which is a group of models. That gives us a bit of a safety net. If one model is off, the others can help smooth things out. Below that, we have got the policy network. This one's responsible for choosing actions. It learns a function that we can write as like that here, and that's the probability of taking action given the current state S. So it sees the state and tries to figure out what move to make. Both of these components, models and policy, get updated as the agent trains. When the models training, we will see the background highlight a bit to reflect that. Same goes for the policy when it is being updated, and here you can also track the model error. It starts out high and ideally goes down over time. And experience collection here. How experience gets collected and used. On the left, you can see the number of steps taken in the real environment. It's currently at 10. On the right, we have the number of steps taken using the model. Here it is at 40. So the agent is doing 4 times more learning through the model than it is in the real environment. That's what the efficiency ratio tells us. It is around here 4 times right now. The reason that's helpful is because model-based learning is cheaper computationally, but again we still need some real-world interaction to keep things grounded. Now if you scroll down a bit, we will see a full flow of the MBPO algorithm. It goes like this. First, the agent collects data from the real environment that gets stored. The model is then trained using that real data. Once the model is going enough, it generates synthetic rollouts. These are fake but useful interactions based on the learned model. The policy uses those to improve itself, and we also adjust the planning horizon depending on how accurate the model is. So if the model is doing well, we can afford to simulate a bit further into the future. If the model's error is high, then we keep the horizon short to reduce compounding mistakes. Okay, now here we are looking at the model rollout and planning section. This part is about how far into the future the model is allowed to simulate. And right now the planning horizon is set to k equals 5. That means we generate sequences that are 5 steps long using the model. Short rollouts help limit error propagation because the model gets less accurate the further it tries to predict. We don't want to go too far out if we can avoid it. You can also control the ensemble size here. That's how many models we are using at once, and right now it is set to 5. Increasing this number helps make predictions more stable, especially when the dynamics of the environment are a bit messy. Okay, and the visual just below shows these rollouts as branches, and each line is a sequence the model thinks might happen from a given state. The more confident the model is, the more consistent these branches will look. And on the far right, we keep track of the total reward the agent is earning as it moves through the simulation. And concepts and ideas is here. Okay, one thing we really have to keep an eye on is model error. The more steps the model tries to simulate, the more its predictions can drift from what actually happens. So to manage that, MBPO keeps rollouts short, uses multiple models, and adapts the rollout length over time based on how well the model is doing. And if you look at the learning setup, it is hybrid. On one side we have got model-free learning. This uses real environment data and is stable but slow. On the other, model-based learning uses synthetic data and is more sample efficient. MBPO blends both. Okay, and it uses real data to train the model, then uses the model to generate more data to train the policy. And what are the main advantages? First, it is sample efficient. You can get results faster because you are not always waiting for real world feedback. Second, it has mechanisms in place to keep model error under control. And you still end up with performance that's close to pure model free approaches but with far fewer steps. And finally, it is scalable. It works well on tasks that are hard to simulate or too slow to train entirely through trial and error. So that's the general review, and thank you for listening.